Pluto, an exoplanet and now the most famous dwarf planet in our solar system, is hiding somewhere far, far away in its dark corner. The temperature of Pluto's surface is freezing. I mean, wow! At first sight, it's just a distant, icy, and barren celestial body. But could Pluto be hiding something? Maybe even life? Scientists found out that, despite it being so far from the Sun, its interior is still warm. It's been that way ever since Pluto formed. Under the haze-layered atmosphere of Pluto, there's a frigid surface full of craters and impure water ice. There's also a large impact basin flooded by frozen nitrogen. And below that icy crust could be an internal ocean. When the surface of a planet stretches, it mostly leaves many fractures behind. The same goes with Pluto. You can see there are numerous cracks across its water-ice crust. They're of all ages. Some even possibly date from 4.5 billion years ago, from the times when Pluto was still forming. The dwarf planet probably grew because it slowly accumulated small pieces of icy material. It condensed during the time when the outer region of our solar system was forming. This process was going intensely and fast enough to melt the base of the icy layer. The surface of Pluto extended as liquid water at the top of the ocean froze onto the base of its ice crust during its first 500 million years. The ocean may have stopped freezing for the next billion years. The buildup of radioactive heat temporarily balanced the rate of heat escape to space. But as Pluto produced less radioactive heat over time, the roof of its interior ocean continued to freeze, and it probably turned into a 120 miles thick layer between the rock and ice. Crusts were the first hint there might be an ocean there. Scientists got the second potential piece of evidence when they realized the icy shell had managed to glide across an essentially frictionless interior and reorient itself. And it's not just about the ocean here. The cool thing is that wherever there's water, there could be life. A potential ocean under an icy crust is not something that possibly exists only on Pluto. Some icy moons of our solar system have it too, like Saturn's moons Enceladus and Titan, and Jupiter's Europa. Enceladus and Europa could both have salty liquid oceans. Plus, they have similar water plumes erupting from their interior. These geysers tell us these moons have their own source of energy, probably because of radiation or gravity. Either way, that energy is what could support life. Have you heard of Ceres? It's our closest dwarf planet, the biggest object in the asteroid belt between Jupiter and Mars, and the first asteroid we discovered at the beginning of the 19th century. People even called it a planet then. Although it's not so popular, there's a possibility Ceres has a subsurface ocean too. Geysers could be the first sign of that. The water vapor plume could be a result of a meteorite strike that exposed subsurface ice to outer space. Ceres may have its own atmosphere too. This dwarf planet is relatively far from the Sun, but its surface temperature could go up to -37 degrees Fahrenheit. At these temperatures, if there was water ice at its surface, it would quickly change to gas, and this could create an atmosphere around this intriguing dwarf planet. Not just oceans, there are many volcanoes across our solar system too. Mercury, Venus, Mars, and Io, one of Jupiter's moons, have them. But apart from the Earth, Io is the only one that has more than 400 active volcanoes. 150 of them erupt at any given time. Scientists suspect there could be some volcanic activity on Venus and Jupiter's moon Europa too. But they can't check if that's true because Venus has an extremely thick atmosphere and Europa has a thick ice shell. And even though volcanoes in other spots are no longer active, we know they used to be because of specific landforms they left behind: hills, valleys, plains, mountains, and especially lava channels. It's like when you're watering your plants on the front porch, you see water flowing down your sloped driveway along specific pathways. This creates small channels, a lot like lava does. Our moon may have also had active volcanoes back in the age when dinosaurs were still roaming around. If they had had telescopes, they might have seen something spectacular: lava fiercely oozing from the surface of the moon. Astronauts took images of Ina, an unusual volcanic deposit on the moon, and there are 70 similar patches in the volcanic plains they found on the side of the moon that faces our planet. Some of them are over 1 billion years old, but some could have been formed less than 100 million years ago, and dinosaurs went extinct 66 million years ago. Speaking of dinosaur extinction, could Jupiter have been the main culprit for that? No one knows where this space rock that hit our home planet 66 million years ago came from, especially with such force. It left a crater off the coast of the Yucatan Peninsula in Mexico, and it probably caused earthquakes, tsunamis, and fierce volcanic eruptions that brought troubles not only to dinosaurs, but to nearly 3/4 of all animal and plant life on Earth. But some believe Jupiter was the one that flung the comet into the Earth. Gravity is a tricky force that can make the solar system act like a big pinball machine. Jupiter is our most massive planet, which means it has extremely strong gravity. It's like a guardian of our solar system that kicks many incoming comets away, sometimes bringing them pretty close to the Sun. As they get there, these comets can experience extremely strong tidal forces that break them apart and, in the end, create long chunks of a comet. And one of these chunks probably went towards the Earth. Have you heard of the story of Triton? Neptune has 13 moons, and Triton is the largest of them. It's the only giant moon in our solar system that has a retrograde orbit. It means it circles its parent planet in the opposite direction of its rotation. Scientists believe that's because Triton used to be in the Kuiper Belt, a disc-shaped area located in the outer solar system, past Neptune's orbit. And it's possible that Neptune's gravitational force pulled it out of that region millions of years ago. Pluto may have originated within the Kuiper Belt too. Pluto and Triton are almost the same. They have similar density, mass, and surface material. Now Triton is locked away in synchronous rotation with its parent planet Neptune, far away from what we believe is its homeland. Now, the most distant object we've discovered so far in our solar system is a mysterious planetoid called, wait for it, Far, Far Out. 1 astronomical unit is the average distance between the Earth and the Sun, around 92 million miles. Well, Far, Far Out is 132 astronomical units from the Sun, 4 times farther away than Pluto. Since it's so far away, Far, Far Out needs about 1,000 years to finish a single circle around the Sun. Far out! Have you ever imagined what would happen if 2 gas giants collided? The chances are small, but if something like this happened, not much matter would be lost, although it depends on the angle and the speed of impact. A head-on collision would make them completely merge and not lose any matter at all, whether we're talking about their gaseous envelopes or their solid cores. But at high speed, their 2 cores would merge and both planets would lose most of their envelope gas. At very, very high speeds, bam, both are gone. If there was an oblique collision, 2 cores could completely avoid each other. Planets would merge, but a substantial fraction of their gases would vanish into space. And in a very oblique collision, kind of like a sideswipe, planets would keep going like nothing happened. There's no evidence for that, but one theory even says Jupiter and Saturn, or at least one of them, might have formed by merging from smaller gas planets. Yep, it's all about gas. Pluto used to be considered a major planet, but later was reclassified into something called a dwarf planet. Something too big to be an asteroid, but too small to be taken seriously. How rude. But recently, scientists began to discuss the mystery surrounding one of Pluto's moons. It turns out it might be even cooler than all of us. It might be a double planet system. Pluto is residing in the distant Kuiper Belt. It's a vast area in our solar system, like a big rocky suburb beyond the orbit of Neptune. It's filled with small icy objects, similar to Pluto, called Kuiper objects. They're leftovers from the early days of our solar system and give us clues about how it was formed. It's where many comets come from. You already know that it's small, but it's remarkable just how small it is. Pluto has a width of about 1,400 miles. It's about half the size of the United States and smaller than our moon. Pluto's atmosphere is very thin and composed of nitrogen, methane, and carbon monoxide. Stinky. It's also very cold there, with average temperatures being around minus 390 degrees Fahrenheit. Its orbit around the Sun looks like an oval, and 1 year on Pluto takes around 250 Earth years. Pluto also shows a strange and unusual retrograde rotation because it's tilted on its axis, which means that it spins on its side. If you were standing on Pluto, you'd see a lot of high icy mountains, valleys, plains, and craters. The sun would be very dim and far away, and it would always look like twilight. It's a colorful planet, surprisingly. You would see a rainbow of pale blues, yellows, oranges, and deep reds. And the most adorable fact about Pluto is its famous heart, called Tomba Regio. Pluto was discovered super late in the 1930s, later than the rest of the planets. Initially, we thought that it's the 9th planet in our solar system. However, the more we explored the Kuiper Belt, the more we realized that it's full of these medium-sized objects. We found 4 more little planets just like Pluto: Eris, Ceres, Makemake, and Haumea. They all shared the same characteristics, and that's where we figured out that Pluto belongs to another family and created a category of dwarf planets. There are a couple of differences between these two categories. The first obvious difference is size and mass. Major planets are much bigger and more massive. They also have to be spherical, while dwarf planets might not be perfect spheres and might have weird shapes, like an egg-shaped Haumea, for example. And just like a regular planet, a dwarf planet orbits the Sun, but it doesn't have a clear orbit. Its orbit is full of debris and random objects. These are the only differences between the two. Well, as you can imagine, the reclassification sparked quite a controversy. People even made up a new term, Plutoed, which means downgraded. But although it might be sad that Pluto isn't a major planet anymore, we can look at it like a story about finding your true family. And finally, while standing on Pluto, you would see its 5 moons: Styx, Nix, Kerberos, Hydra, and the most mysterious one, Chiron, also pronounced Charon. So you can pronounce it however you like. I'm going to go with Charon. Now Charon is Pluto's largest moon. It was discovered in the 70s thanks to NASA's spacecraft called New Horizons. The spacecraft took a picture that revealed a moon with a strange and fascinating huge red-brown spot on its surface. It's a vast canyon dwarfing the Grand Canyon. It seems that both Pluto and its moon can boast interesting formations on their surface. The thing about Charon is that it's very big for a moon. It's about half the size of Pluto. This makes scientists wonder, could it be that Pluto is a double planet system? The center of mass, or barycenter, of Pluto and Charon lie outside of Pluto. Normally, with planets and their moons, the center of the planet itself should be the center of the mass, with the moon orbiting around it. But in the case of these two, it seems like they orbit each other. Binary objects are quite common in the universe. These cosmic pairs form just like our moon, from giant impact events. But double planets are exceedingly rare, and we haven't discovered any double dwarf planets yet. So, if it's true, then Charon is actually the 6th dwarf planet, and that would be our first binary dwarf planet system ever. There's also another candidate, the dwarf planet Eris and its moon Dysnomia. The solar system is full of mysterious and fascinating moons, so fascinating that some of them might not even have actual life on them. We've been talking about microscopic life in space for a while now. The debates about whether we found some organic fossils on Mars or not have been going on for decades. With the development of our technology, we're finally getting onto something. Meet Enceladus, who has stolen the spotlight since NASA's Cassini probe arrived there. Enceladus is covered in a sort of snowy blanket, which is why it's so unusually bright and has some snow-covered craters. It's small, only about 310 miles, and is mostly composed of simple rock and ice. But in 2004, we found plumes of water bursting out from this moon's south pole, which means that there's liquid water beneath this moon's icy surface. It's probably because of Saturn and its other larger moon, Dione. Their gravitational dance creates tidal forces that keeps Enceladus warm and lively. All this means that Enceladus is now a top candidate in the search for life within our solar system. Of course, life requires more than just water, and we won't find any animals there or anything like that. But we might find some microscopic organisms, and that's awesome too. In fact, Saturn is winning the lottery when it comes to life candidates. For example, scientists have a wild idea that Titan, another of its moons, might be home to extraterrestrial life as well. Titan is a frosty moon, chilling at about minus 290 degrees Fahrenheit. Surprisingly, it has some lakes on its surface. But don't imagine your typical water bodies. These lakes are believed to be filled not with water, but with liquid ethane or methane. Back in 2005, NASA discussed that there might be life munching on chemicals like acetylene or hydrogen in Titan's lakes. And then, in 2010, NASA investigated this moon some more. They found missing hydrogen and acetylene on Titan's surface, hinting at the possibility of something eating away at these substances. That's why some scientists dare to imagine methane-eating beings in Titan's freezing lakes. Moreover, they suggested that if these creatures exist, they probably have much larger cells than animals on Earth. What we could find there is something much bigger than a simple microbe, even something like a small animal. But Saturn isn't the only lucky one. Triton is Neptune's biggest moon, and you guessed it, it's another life candidate. It's an icy world with frozen nitrogen all over its surface and a crust made of water ice, again super chilly. However, Triton is a hotspot for geologists because it's one of just 5 moons in our solar system that likes to show off with its active geysers. It's shooting nitrogen gas up into space. That would be a cool show, if we could see that. These geysers mean that Triton has some secret source of warmth, which means that, just like with Enceladus, there might be some liquid water underground on Triton. And if this cozy spot for life does exist, we might find some organics there. Unfortunately, sending a mission to explore these celestial bodies isn't easy. The only spacecraft we've sent so far was our Voyager 2 in 1989. We need more time, money, and technology to develop spacecrafts that would be able to travel far and investigate the area beyond Mars. And even if we do, it'll take decades for this spacecraft to reach these places. In any case, let's hope that during the 21st century, we'll finally be able to fully explore our solar system and all its mysteries. As you know, all the planets in our solar system orbit the Sun and bring a sense of order to the place. But guess what? There are 2 planets that could collide with each other and cause a cosmic catastrophe. Here's Neptune, the most faraway planet in our solar system. It's 17 times heavier and 4 times bigger than the Earth. It's 30 astronomical units from the Sun. 1 AU is the distance between the Sun and the Earth, so it's 30 times farther away from our star than we are. And Neptune makes a complete circle around the Sun in 164 years in an almost perfectly round orbit. Neptune is cold, calm, and stable. But there's one planet that can ruin this balance: Pluto. It's a dwarf planet covered in rocks and ice. It's 6 times lighter and 3 times smaller than the Moon. We're interested in its orbit. If you look at a map of the solar system from above, you can see that it's not round but elliptical, so it's a slightly flattened circle. At its furthest point, Pluto is 49 Earth-Sun distances away from the Sun. When it moves, it comes closer to the star. At its closest point, Pluto is about 29.5 AU from the Sun. That's closer than Neptune. So, hypothetically, they could collide. Let's look at this collision from the front row. A little closer, please? Good. Neptune and Pluto are slowly approaching each other. They are both very cold worlds, but they begin to interact with each other gravitationally. Just like 2 magnets, it warms them up from the inside. Neptune is a gas giant. There's no solid surface there, so there's not much change in it yet. But Pluto has a rocky surface. Because of Neptune's gravitational influence, it's starting to crack. Pluto experiences continuous earthquakes. This causes it to heat up even more. When Pluto almost touches the gas giant, it begins to crumble from the inside out. Plus, Neptune has a very dense atmosphere, so the dwarf planet begins to ignite from friction with the gases in the upper atmosphere. Pluto is now very hot on one side and very cold on the other. This causes severe deformation, and it begins to crumble. Half of the dwarf planet's fragments remain in Neptune's orbit, They will collide with each other until they turn into dust and become new rings of the big planet. Other fragments will burn up in Neptune's atmosphere, and the biggest rocks that remain of Pluto will fall through Neptune until they're completely burned into dust. Neptune literally ate Pluto and continued its orbit without any change, all because the gas giant is 20 times larger and much heavier than the dwarf planet. So this collision would do no harm to Pluto. But it couldn't have happened in the first place, because their orbits don't actually cross. Let's look at the map of the solar system again, not from above, but from the side. All 9 planets here are on a horizontal line from the Sun. The distance between them is great, and their orbits don't cross. Here's Pluto's orbit. You can see that it's tilted relative to the horizontal line of all the other planets. It starts at the top, then dives under the orbits of the planets and comes back. So Pluto can never collide with Neptune. Still, planetary collisions have occurred in our solar system before, and thanks to these collisions, life appeared on Earth. Let's go back in time to almost 4.5 billion years ago. This ball of hot lava is Earth. It just formed from a cloud of dust and began to cool. But then, a wandering planet the size of Mars appeared on the horizon. It's called Theia. It was inevitably approaching our planet. The collision with Theia happened at a perfect angle. If Theia had hit us head-on, both planets would have been smashed to pieces. But it hit us almost at a tangent. Theia knocked some of the matter out of the young Earth and crumbled into rubble itself. It could no longer continue its journey because the Earth caught it in a gravitational trap. A large fragment of this planet remained in our orbit. Smaller fragments crashed into each other, falling to Earth or joining the remains of Theia. The dust settled, and we can see the familiar picture, the Earth and the Moon. This is the main theory of how it came to be next to us. Scientists say that it was this collision that caused life to appear on Earth. Theia brought a lot of ice on it, which turned into water on our planet. The new moon stabilized Earth's rotation, and conditions on the planet became perfect for the emergence of life. Another collision could create a blast wave that would spread out thousands of light years. Stellar collision. This usually occurs in binary systems with a white dwarf and a regular star like our Sun. A white dwarf is the remains of a star that has gone out. As the stars get together, they start to move around each other in a spiral-like dance. The white dwarf pulls down the upper layers of the larger star. This hot plasma and stardust form a luminous disk. The two stars get closer and closer. When they finally merge, this causes a chain reaction in the core of the hot star. The mass of matter presses on the star's core too hard. This causes the innards of the combined star to heat up even more, and it expands, creating a supernova. This is one of the brightest events in the universe. The light from the explosion can be seen hundreds of light years away. Another spectacular view is the collision of a star with a black hole. Black holes are the heaviest objects in the universe, and their gravity is incredibly strong. So when a star and a black hole get close, the black hole starts eating the lighter matter of the star. The hot plasma, like spaghetti, heads toward the heart of the black nothingness. For an observer, this plasma seems to settle on the very edge of the black hole. It's called the event horizon. The thing is that time is much slower near such a heavy object. So we think the matter stays on the event horizon, but in fact it's long gone into the heart of the black hole. As they get even closer, the black hole starts to literally tear the star apart and swallows it whole. At this point, the black hole spits out about half of the star's mass in the form of a beam of energy right out of its black heart. The other half of the star's mass becomes the black beast's food. We know of many black holes in our universe. The heaviest of them usually lies in the centers of galaxies. They can be millions of times heavier than the Sun. But what would happen if two black holes collided with each other? Our scientists had the opportunity to observe such an event. Two black holes weighing 66 and 85 solar masses gradually approached each other. They danced together, bending the light passing by them. But then they merged into one enormous black hole, weighing 142 solar masses. That same second, the new black hole released gravitational waves into space with an energy of 9 solar masses. Scientists were able to catch these waves and observe the merging of the two black holes from the front seat. But this event actually happened about 17 billion years ago. We're only now seeing it because the particles of light and gravitational waves took so long to travel the distance of 17 billion light-years to Earth. Now consider a galactic scale collision. Literally, it's a collision of the Milky Way and the Andromeda Galaxy. This event will happen in 4.5 billion years, so stay tuned. The Milky Way has almost 100 billion stars. Andromeda has about 1 trillion. As the galaxies approach one another, they'll make several circles around each other. At that time, some stars may be ejected from the galaxies like from a slingshot. Then Milky Way and Andromeda will begin to merge. One scenario here is that our solar system will collide with another star system from Andromeda. In this case, there could be a stellar collision and a supernova afterwards. Our world would be destroyed. Another option is that the Sun would be ejected into dark space. In this case, we may not even notice the difference. All we'll see on Earth is a gradually disappearing starry sky, as our solar system will travel through dark space away from the home galaxy. But the most likely scenario is when the galaxies merge, it'll be completely painless for us. In fact, the space is very wide, and there's room for all the stars from both galaxies. The only difference is that we'll see a lot of new stars in the night sky, along with flying saucers from Andromeda. Nah, not really. But it's not the collision of galaxies that we should be worried about, it's our Sun. In 4.5 billion years, it'll become a red giant. It'll expand, swallowing up the nearest planets. Earth will probably be the first planet near the Sun. It'll be so hot that all life will simply disappear, and no one will be able to watch the galactic collision. Frozen plains, mountains with white peaks glistening in the distant sun, and rustic red snow. Welcome to Pluto, where nothing makes sense anymore. Looking at it from a distance, the ice ball planet is mostly predictably winter shades of white and light blue. Once you land on the surface, you'll notice familiar blue skies as well. But see that whale-shaped red stain running along the equator? Right there to the left of the white heart-shaped region, there she blows. This spot is bigger than Alaska, and it's a mystery to scientists. That's not red clay soil or anything you'll see on Earth. That's Pluto's version of ice. Scientists believe it's red because the atmosphere drops this strange soot-like chemical called tholin on the surface. It's the same stuff that explains the red cap on Pluto's moon Charon. Now let's zoom in closer on the whale. Oh look, we have a mountain range. Yes, Pluto's red ice is like rock, hard enough to form entire mountains. Those white peaks standing out against the dark red aren't snowy caps like we have on Earth. That's frozen methane. For such a small planet, Pluto's mountains are epic, bigger than Everest and made entirely of ice. Such a bizarre landscape can't be found anywhere else in our solar system. Yeah, Pluto's a pretty harsh cold place. Temperatures there can dip to minus 400 degrees Fahrenheit. The coldest ever recorded on Earth was in Antarctica, a measly minus 135. Now let's head back to the heart of Pluto. That's actually a vast plain covered in nitrogen ice. Scientists discovered that Pluto's heart makes the winds on the planet blow. Craters are also big, and some of them show signs of filling and erosion. That's something that happens right here on Earth. When land is worn away and shaped by natural forces like wind, water, and ice, that's erosion. So, what makes all this so special on Pluto? It could be evidence of tectonic plate activity. You know, big plates of land surfing on liquid rock, forming mountain chains, breaking continents apart, putting them back together. That's something scientists so far have only ever seen on Earth, not on any other planet in the solar system. Now, looks like Pluto could be more like our own planet. That, and there's water on Pluto, 1/3 of its surface in fact. But of course, it's not like Earth water. It's more like a rocky slushy. Yum. Still, no signs of life out there, at least not for now. It's taken a long time to get the little information we know about Pluto. It was first discovered almost 100 years ago and deemed the 9th planet from the Sun, until 2006 when its official planet membership card was revoked. Poor Pluto. It was dubbed the biggest dwarf planet in the Kuiper Belt, a region outside our solar system full of other dwarf planets and icy bodies circling the Sun. A few months before that, they launched the New Horizons mission. It was the first space probe researchers sent to Pluto in 2006. Zipping at over 35,000 miles per hour, that's 45 times the speed of sound, it still took the probe almost a decade to reach its destination. That's how far away the tiny planet is. In fact, Pluto is nearly 40 times the distance from Earth to the Sun. If you were there looking up at the sky, you'd see the Sun as a tiny dot like any other star in the sky. Once New Horizons finally reached Pluto in 2015, it got close enough to get some incredible pictures of the surface. It also collected important data and observations, like those strange red spots and that heart-shaped region. But Pluto gets even stranger, especially its orbit. Most other planets go around the Sun in almost perfect circles with the Sun close to the center. The Sun is nowhere near the center of Pluto's orbit, and the orbit is so stretched out that Pluto sometimes crosses into Neptune's path and gets closer to the Sun than the blue gas giant. So, the unusual effect of the strange orbit? Pluto sometimes has an atmosphere and sometimes not. When it's closer to the Sun, a thin atmosphere of nitrogen forms. But once the planet starts moving further away from our Sun, the atmosphere freezes and falls to the surface in an ice storm of epic proportions. Pluto is probably a lot smaller than you imagine. If you put it on a map of the Earth, it would only span about halfway across the US. Yet this little planet has 5 moons spinning around it. And life on Pluto would be one endless year for us humans. Imagine no birthdays your whole life. Since it was discovered in 1930, we still haven't seen it complete a full circle around the Sun. 1 year on Pluto is 248 Earth years, and we'll finally see that happen on March 23, 2178. Mark your calendar. Since Pluto got kicked out of the official Planet Club, Neptune became the last one in line. It's actually a big ball of ice and gas. So, like with the other gas giants, if you try to land on this planet, you just keep going deeper and deeper into seemingly endless clouds and atmosphere. Funny thing about the blue planet, it might not have a rocky surface like you and I are used to, but its surface-level gravity is about the same as Earth's. Same can't be said for any other planet in the solar system. As we make our way closer to the Sun, we pass the next gas giant, Uranus, that non-conformist planet that goes around the Sun basically rolling on its side. One full orbit is 84 Earth years, so you might be lucky enough to celebrate your first birthday in your whole life there. Only one party, so you better make it count. And now we approach the jewel of the solar system, Saturn, the second biggest planet after Jupiter and another gas giant where you'd sink in an endless atmosphere if you tried to land a spaceship there. Saturn is the least dense planet of them all, meaning if you put it in a giant glass of water, it'd float. Those famous rings are made up of dust, ice, and rock. Some as tiny as a grain of sand, others bigger than houses. But get this, Saturn's rings are raining down on the planet, enough to fill an Olympic-sized pool in a half an hour. At that rate, the famous blue ring system will disappear completely in 300 million years. By the way, Neptune, Uranus, and Jupiter also have rings. They're just not as visible and bright as Saturn's. Imagine combining all the planets into one. Now make it 2 times bigger. Still not as large as Jupiter. Scientists called it a failed star, since it's mostly made of helium and hydrogen, just like our Sun. But jumbo-sized Jupiter still isn't massive enough to kickstart the chemical processes that could turn it into a star. It's the fastest spinning planet, so it takes only 10 hours to complete a full rotation on its axis. Imagine trying to squeeze sleep, work, friends, hobbies, movies, shopping, your whole routine in less than half an Earth day. Magnificent tall mountains, the highest in the entire solar system. The most epic dust storms ever. Deep valleys, craters. I'm talking Mars, our potential home in the future. If you love sunsets, you'd definitely enjoy Martian ones. They're incredibly blue, while the sky throughout the day is pinkish red. Even though Mars is our closest neighbor, from the surface, the Sun would look half the size it does from Earth. So, not as close as it seems. Oh, and if you always dreamed of becoming a basketball player, Mars is your place. The red planet's gravity is only 37% of Earth's, so you jump 3 times higher there. Venus is a planet of extremes. The hottest surface, the most volcanoes, the brightest planet, and the closest one to Earth. It's also the slowest spinning and barely rotates, making a day on Venus last 243 Earth days. You could literally walk faster before the planet makes a complete turn. Venus also rotates in the opposite direction that Earth does, so sunrises are in the west and the sun sets in the east. Mercury. It doesn't have any moons or rings, and we're talking about the smallest planet in the whole solar system. A year lasts only 88 days, so if you live there, you'd have a lot of birthdays. Mercury is the closest planet to the Sun, but it's actually not the hottest. That prize goes to Venus. Temperatures on Mercury don't get as high as on Venus because it doesn't have an atmosphere to trap heat from the Sun. What Mercury does have is wrinkles. Its iron core cooled and shrank, causing the surface to contract too, and leaving all those wrinkles. That, or because it's so close to the Sun with no SPF. Maybe. Now, if Earth were the size of a nickel, Neptune would be about as big as a baseball. That's impressive, but it's nothing compared to the giant ninth planet that might be hiding out there. Now, our Planet 9's discovery saga might have finally come to an end. Turns out, the problem wasn't where we were looking, but how. And researchers might have just made the biggest solar system discovery in decades. You see, the idea of finding a planet beyond Neptune has been around for years now. I know, back in school, you probably learned that the ninth planet was Pluto. But forget about Pluto. It's been demoted to a less fancy category since 2006. What I'm talking about is the Planet 9, a hypothetical giant planet that could be our cosmic neighbor. We've never actually seen it, but scientists are pretty sure it's out there somewhere, hiding in the outer solar system. To explain why they think that, we need a sheet of paper. Hey, here's one. We place a coin on it, and suddenly, it starts to move. Unless we're talking about some kind of superpower, there's no way this coin is moving on its own, right? So, you figure someone must be on the other side, holding a magnet and moving it around. You can't see the magnet, but it explains why the coin is moving. That's kind of what's happening with Planet 9. We can't see it, we can't prove it, yet, but its existence could explain the strange movements we see out there in space. For example, the planets in our solar system orbit on a flat plane that's tilted about 6 degrees relative to the Sun. But why 6 degrees? Well, no one really knows for sure. Some scientists think those orbits might be slightly tilted because of the pull of a ninth planet. Its existence could also explain the unusual paths of smaller objects in the distant Kuiper Belt, a region full of icy debris that stretches far beyond Neptune's orbit. Back in 2016, researchers from Caltech published a study about Planet 9. They suggested it could have a mass about 10 times that of Earth and follow a highly elongated path. That's a scientific way of saying it takes forever to make one trip around the Sun. Because of that, it would be located in the outer solar system, far, far away. It would orbit the Sun about 20 to 30 times farther out than our most distant planet, Neptune. According to scientists, Planet 9 would take up to 20,000 Earth years to complete just one full orbit around the Sun. Since it's crazy far out there, it's almost impossible to see it. So, as cool as this hypothesis sounds, we've never found solid evidence that Planet 9 actually exists. But we might be pretty close. In May 2025, a team at National Tsinghua University might have made one of the most exciting solar system discoveries ever. Alright, so there's a hypothesis that Planet 9 hasn't been discovered yet because we haven't been using the right method. This new study raises an interesting question. What if Planet 9 actually looks brighter in infrared light than it does in visible light? Let me explain. Scientists have been trying to spot Planet 9 by its reflected light. But here's the problem. To spot it in visible wavelengths, sunlight would have to travel all the way out to Planet 9, bounce off its surface, and then travel all the way back to Earth. If a Neptune-sized planet were about 10 times farther away than Neptune, it would look about 10,000 times fainter. But a planet's own thermal radiation, its heat, only has to make a one-way trip. So in infrared light, Planet 9 would only be about 100 times fainter. That's why it makes more sense to look for it using space-based infrared telescopes. And that's the idea behind this new study. The team started digging through archives, searching for old infrared sky survey data, and they pulled it from two main sources. First, IRIS, a satellite launched in the 80s that scanned the sky for almost a year. Then, the Japanese satellite Akari, another infrared observatory that operated between 2006 and 2011. So basically, they compared objects that showed up in IRA's database and noticed which ones had moved by the time Akari took its observations. And by doing that, the researchers found something incredible, an object that might just be our long-lost ninth planet. Because if something moves, it could be a planet orbiting the Sun, right? And yeah, they did find some celestial objects showing tiny movements. But before jumping to conclusions, they had to rule out the parallax effect. And that's something really important when we're talking about solar system discoveries. To explain it, I need you to do something. Hold one finger in front of your face. Close one eye, and now switch. Your finger seems to move a tiny bit, right? That's because you're looking at it from a slightly different angle, from one eyeball to the other. The same thing happens when we look out into space from Earth. Since our planet orbits the Sun, our view of very distant objects shifts just a little. That effect is called parallax. My point is, because of this effect, Planet 9 would appear to move across the sky as Earth goes around the Sun. On any given day, it might seem to be in one spot, but 6 months later, when Earth is on the opposite side of the Sun, it would look like it shifted. 6 months after that, it would seem to move back again. Scientists had to account for parallax. Actually, they had to remove its effects. So the team looked at images of the sky taken on the same date every year. Because on that same date, Earth is always in the same spot in its orbit. That means if Planet 9 is real, it would show up in the same place in those images every year. No fake wiggle from parallax, just its real position. This careful search led them to a single object, a tiny dot in the infrared data. This strange little spot had moved slightly along its orbit around the Sun over the 23 years between Iris and Akari. Wait, could that be it? Did astronomers just confirm a hidden planet? Well, maybe. But don't get too excited. The data we have on its motion over that time is not enough to figure out its full orbit. So, for now, we still can't say for sure if this mysterious object is really Planet 9. It's definitely a strong candidate, though. Based on how bright the object appears, the team estimates it could be pretty massive, and that came as a big surprise. You see, previous NASA research ruled out any Jupiter-sized or Saturn-sized planets hiding out there, but a smaller world would have gone undetected. So the scientists were looking for something just a bit bigger than Earth. But it turns out this mysterious planet might be more massive than Neptune. Now that they've discovered Planet 9, supposedly at least, the plan is to keep tracking it and collecting new data. But don't think the road ahead will be easy. Because since the Akari satellite spotted it for the first time, that object didn't just sit still. It's been moving slowly through space ever since. So now scientists need to use regular telescopes on Earth to look for it again. And here's the tricky part. They're not exactly sure where it moved to, so they have to search a pretty big patch of the sky. And so far, no matching object has been found. Whether this really turns out to be the Planet 9 discovery or not, only time will tell. For now, its existence is still up for debate. But with powerful new technology on the way, like NASA's Nancy Grace Roman Space Telescope, astronomers are more determined than ever to uncover the truth. And if Planet 9 really is out there, hiding in the cold, dark edges of our solar system, it's running out of places to hide. Now, Jupiter used to be flat and look like an M&M candy. Now I'm hungry. And it wasn't the only flat pattern in our solar system. Turns out there are tons of things that can go wrong during a planet's formation, like locking up to the Sun or getting whooshed into open space. Let's check it out. The Earth isn't flat, but Jupiter might have been. Instead of being a big round ball, gas giants in our system might have started more like flat pancakes. Jupiter is one of the oldest of our neighbors. It's 4.6 billion years old, just like our Sun. And when it was just a baby planet, it likely formed through a process called disk instability. It all begins with stars. When a star is forming, it doesn't look like a round object. It's more like a big disk of stuff. During this stage, really hot winds made of charged particles blow out. The dust in that disk contains stuff like carbon and iron. Some of them collide and stick together, forming bigger objects. Dust turns into pebbles, pebbles turn into rocks, and rocks bump into each other, getting bigger. Gas in the disks helps all these solid bits stick together. Some break apart, but others stick around, and they're the ones that become the basic pieces of planets. They're called planetesimals. Even gas giants like Jupiter started off as tiny specks of dust, smaller than a human hair. Eventually, they formed their own big ring-shaped disks of gas. They began to spin around our sun, growing bigger by gathering gas and rocks like snowballs. Gas giants are special. They were born from the colder parts of the disk. In cold areas, molecules are slower, which makes them easier to grab. In these places, water could freeze, and tiny ice pieces stick together and are mixed with dust. These dirty snowballs gather up and then form cores of huge planets, like Jupiter, Saturn, Uranus, and Neptune. In the warmer areas closer to the star, rocky planets like Mercury, Venus, Earth, and Mars start to form. After the icy giants were born, there wasn't much gas left for these smaller planets. It might take tens of millions of years for these rocky planets to form after the star is born. And our sun was growing at the same time, sucking up nearby gas and pushing faraway stuff even farther out. After billions of years, the disk changed completely, turning into a round star with a bunch of planets, dwarf planets, asteroids, moons, meteoroids, and comets around it. Recently, simulations showed that these protoplanets, as these early dust balls are called, don't start off looking like the planets we know. In the case of gas giants like Jupiter, they look more like squashed balls or M&M's candies, not the peanut kind. When the sun was young, the disk of gas and dust surrounding it cooled down and became unstable. It started breaking into big chunks. These chunks dramatically collapsed together under huge gravity to create Jupiter. It became a round gas giant over time. There are a lot of oddities that can happen during that process of planet formation. Ever wonder why Venus or Uranus spin in the opposite way compared to other planets? Usually, when things form from a spinning disk of gas, they tend to spin in the same direction. For example, if you spin a bunch of balls on a string, they all twirl in the same way. So, theoretically, all planets should spin in the same direction too. But there are a lot of fast-moving objects like comets and asteroids in our solar system. When they smash into planets, especially during their early days, this collision might send the planets to spin in the opposite direction. Venus and Uranus probably survived a massive collision. Luckily, they weren't repelled to outer space. The gravity from the Sun and nearby planets pulled them back into place. There are also so-called tidally locked planets. These are celestial bodies that spin in a way where one side always faces their star while the other side remains in perpetual darkness. So one side is always very hot while the other is extremely cold. If we were on a planet like that, we would only be able to live on a thin line in between. These planets form when they're very close to their star. The gravitational forces are extremely strong, and over time, these forces slow down the planet's rotation until it matches the time it takes to orbit the star. Imagine you're spinning in your chair. Someone comes up to you and, holding onto your chair with their hands, starts spinning with you. This way, you'll always face each other. Tidally locked planets kind of work like that. Our moon is tidally locked to our Earth, which is why we only see one side of it. We've discovered more than 5,000 planets outside of our solar system called exoplanets. Some of them have very strange orbits. For example, planets with incredibly long orbits, thousands of years to make one trip around the star, or very wonky, comet-like orbits, or so-called hot Jupiters. They're super close to their star, way closer than Mercury is to our Sun. But these planets couldn't have formed where they are now. As their solar system evolved, they changed their positions for some reason. This rearranging is called planetary migration. There are three main ways this migration happens. First, because of the gas and dust spinning around the planet. When a planet is bumping into this stuff, it can create spiral patterns in the gas. These patterns can either push the planet closer to the center or farther away, depending on how they mix together. It's called a gas-driven migration. This is what Jupiter experienced when it moved closer to the Sun billions of years ago. I wasn't around then. This also explains the existence of hot Jupiters. Second, big planets can shove the smaller ones, changing their paths. Third, the star's gravity can tug on the planet, making its orbit more circular. Ever heard of rogue planets? Imagine a lonely planet floating in the vastness of space without a star to call home. They're like the wandering nomads of our galaxy, doomed to drift around forever. And there are so many of them, there might be more free-floating planets than ones that are tied to stars. We're talking trillions of rogue planets hanging out in our Milky Way galaxy alone. They're often as massive as our biggest planet, Jupiter, but most of them might be Earth-sized. Some might even have thick atmospheres that keep them warm, even though they're far from any star. Some of them might have wild auroras, while others could host moons with liquid water, a potential haven for life. There's even a chance that they might contain extraterrestrial life. These planets might bump into other stars or even entire planetary systems as they journey through space. Sometimes they might get caught in a star's gravity for a while before getting flung back out into space. But how are they born? Sometimes, during this chaotic process of planet formation, not all planets can manage to stay close to their parent stars. Some of them get kicked out of their solar systems due to powerful gravitational interactions with other planets or passing stars. These ejected planets become rogue planets. In 2012, astronomers found a solar system from the very beginning of the universe. This system included a star and 2 planets. We called it a fossil system. The star is super old, about 13 billion years, almost as old as our entire universe. It was mostly made of just hydrogen and helium. This is unusual because planets usually form from clouds of gas that contain heavier stuff. That's when we figured out that the way planets formed before was different from how they form now. We know that stars with more metals are more likely to have planets. In astronomy lingo, metals means any chemical element other than hydrogen and helium. But in the early universe, there weren't many metals. Most of them were created inside stars and then spread out into space when those stars blew up. So, when did the very first planets form? This newly discovered system helps answer these questions. Its 2 giant planets are orbiting a star that's incredibly low in metals and extremely old. This should be really rare, if not impossible, but they exist. This means that maybe there are more planets in metal-poor systems than we thought. Studying them will help us learn more about the history of planet formation. This planet, the one right here, shouldn't exist, but it does. A newly discovered planet rotates around a star that's much smaller and dimmer than our Sun. The planet, however, is enormous. Such a tiny star couldn't create it, so it's like finding an ostrich egg in a chicken coop. A team at Penn State built a special tool called the Habitable Zone Planet Finder. It's an instrument that's supposed to find planets around dim, cool stars. It's connected to a big telescope in Texas. The tool looks at the light from these stars, which is mostly in the near-infrared, beyond what our eyes can see. This gadget can spot changes in a star's speed caused by a planet. If the star movement slightly changes, that means there must be a gravitational pull nearby. Years ago, this technique helped find the first known exoplanet around a star like our Sun. Today, we've improved this method to make more precise measurements. Our main goal is to find Earth-like planets. They should be rocky and located in habitable zones, areas around stars where liquid water could exist. The Doppler technique isn't that great at finding Earth-like worlds yet, but works well for cool, dim stars. And that's how we discovered the impossible LHS 3154b. Planets usually form in disks made of gas and dust in space. Picture a flat, spinning cloud of tiny particles. These particles come together and stick to each other, creating a flat, rotating disk. Over time, these tiny bits combine to form a solid core. This is the starting point for a planet. Once the core is there, it attracts more dust and even gas like hydrogen and helium. But making a planet this way isn't easy. They need a lot of stuff, mass, and materials. This process is called core accretion. Stars are a huge help in that process. Usually, big stars have more gravity, so they can gather more stuff to form planets. But the star we discovered recently isn't very big. It's 9 times smaller than our Sun. A star this small shouldn't have a big enough disk to make a heavy planet. To do that, its disk should have been at least 10 times bigger. But this heavy planet, LHS 3154b, exists. Now, this mysterious planet is 13 times heavier than our Earth. It's similar in size to Neptune. It's about 50 light-years away from us in the Hercules constellation, which, in space terms, is very close. The planet is also super close to its star, completing 1 year in almost 4 days. This discovery is making scientists rethink their ideas about how planets and stars come into existence. There are new theories coming around. For example, a theory called gravitational instability. It says that, instead of the pieces coming together bit by bit, the material in the disk collapses all at once, directly creating a planet. But even with this theory, it's hard to explain how such a heavy planet could form without a really massive disk. It'll take us some time to figure out the truth. This isn't the first planet that makes us doubt our theories. Recently, scientists found another planet called Hala. This planet is orbiting a star called Baekdu, and just like the previous one, it shouldn't really exist. It's way too close to its star. Stars change a lot during their lives. Normally, when a star becomes big and prepares to leave this world, it's called the red giant stage. A star like that tends to destroy or push away any nearby planets, creating a huge mess. Hala rotates around a red giant, and it should have been swallowed or destroyed by the expanding star a long time ago. But it's still hanging there. Even though Baekdu has already started burning helium and shrunk to a smaller size than expected, Hala isn't bothered in the slightest. Scientists call Hala the Forbidden Planet. This discovery challenges what we thought about how planets survive near aging stars. It raises 2 theories. One suggests that Baekdu was once 2 stars, a white dwarf and a red giant. Hala orbited them both, and they merged before the red giant fully expanded. This allowed Hala to survive because the extra helium from the white dwarf prevented the red giant from growing too much. The second theory says that Hala formed from the debris created when the 2 stars merged. In this scenario, Hala would be a very young planet orbiting an elderly star. Astronomers plan to continue studying Hala and look for more planets like that. Another oddball, besides me, is called LTT 9779b. This one scares us too because it's too shiny. The planet reflects 80% of the light from its star. Regular mirrors reflect from 85 to almost 100% of light, which means that this mysterious planet should look like a rough mirror, with aluminum or silver-like reflections. This is another Neptune-sized planet. It's located 268 light-years from us and was discovered by NASA's TESS spacecraft. It completes a full rotation around its star in just 19 hours. It's so close to its star that it's scorching hot, reaching temperatures over 3,600 degrees Fahrenheit. Normally, planets this close lose their atmosphere and turn into bare rocks. But this one breaks the rules again. Now this time, we know the secret of its survival. It's because of the planet's shiny metallic clouds, which are made of glass and titanium salt. These clouds rain titanium onto its hot surface. They also reflect a lot of the light, preventing the planet from getting too hot and losing its atmosphere. It's like having a mirror shield. This planet's size also surprised scientists. It's way bigger than Earth. Other planets this close to their stars are either much bigger gas giants or small rocky planets. This planet is a smaller gas giant, and scientists didn't expect it to exist so close to its star. This is the shiniest planet ever found, even shinier than Venus. But despite its cool appearance, it's probably not a friendly place for life because of its extreme temperatures and strange metallic rain. And our final rule breaker is a planet called WASP 107b. Scientists discovered it using the James Webb Space Telescope. It's located around 208 light-years from us in the Virgo constellation. It's also fast and completes an orbit around its star in just 6 days. This is a super Neptune exoplanet. It's similar to Jupiter in some ways, including the same size and scorching hot temperatures. But the main difference is that it's much lighter, weaker, and less dense. This is the least dense planet we've discovered so far. After researching some more, we also found that it has a tail. The helium on the planet extends beyond the transit egress. The planet is slowly losing its atmosphere due to extreme ultraviolet radiation from the star. This creates a comet-like tail. So, it looks like a fluffy comet. But that was just the beginning. The planet's low density, or fluffiness, allowed astronomers to study its atmosphere in detail. They found some surprising things, like water vapor and clouds made of fine silicate particles, which are like really fine-grained sand. The planet's host star doesn't emit a lot of high-energy light. But since WASP-107b is so loose, the light can penetrate deep into its atmosphere. This creates sulfur dioxide that smell when you light a match. In other words, it's a fluffy planet that rains sand and smells like matches. The researchers think the sand clouds in the atmosphere form in a similar way to clouds on Earth. They just have droplets of sand instead of water. These sand droplets condense, fall, turn into silicate vapor in hot layers within the planet, and then rise again to form clouds once more. And, once again, this planet couldn't have formed in its current spot. Astronomers say that it likely moved closer to its star from a birth orbit because it was attracted by some heavier neighbor. It also follows a retrograde orbit, meaning it orbits in the opposite direction to its star's rotation. All these discoveries are changing how we understand planets and their atmospheres, giving us new insights into the mysteries of our own solar system.